what's up? It's Ryan. Today we're going to graph some trigonometric functions and get some practice with them so that we're comfortable. Okay, so basically what you need to know about trig graphs is we're essentially relating how the angle of a triangle or the angle on a unit circle changes, how that correlates to our trigonometric value, so a sine or a cosine. So, for example, our x-axis is always going to be our angle, so it's normally going to be in radians, and our y-axis is going to be our trig function, so our sine, cosine, tangent. So it's going to be super helpful for us to know our unit circle. Sorry, this is kind of big, but we're going to use our unit circle to see at exactly pi over 2 what our value of sine or cosine is, and then we're going to graph that on our plane here. So this is what a sine or cosine graph looks like, and it sort of has waves. It repeats exactly in regular intervals, and so they're periodic, right? They have this pattern. They're waves, and so there's some characteristics of a trigonometric. In this case, this trig function is sinusoidal. They have some characteristics, and so one of them is the period, and the period is the length of the cycle, so it's how far it is from this peak to this peak. So we're going to label this period. It also has an amplitude, and that's saying how sort of the distance, half the distance from the minimum to the maximum value. So it's going to be this length right here. This is called the amplitude. Okay, so as I said before, our x value is going to represent the angle, and then our y is going to represent our corresponding trig value. Sorry, that is horrible. Okay, so let's graph sine first. So it's going to be super helpful for us to use our unit circle here. If we zoom in to this sine graph, right, our x-axis is our angle. So when our angle is 0, what is our value of sine going to be on our unit circle? So we go to 0, our angle is 0, our value of sine is our y value, right? So it's going to be 0. So we're going to start at 0. Our starting point for sine is 0. Let's make that a little bigger. Now what about for here we have pi over 2. So we go to our unit circle. What's our y value for pi over 2? It's 1. So we're going to graph 1. Sorry, wait, my bad, that is not in the right place. Okay, so we're gonna graph 1 right here. Probably should change the y coordinates, the y scale, but it's all right. So for our angle, next interval is going to be pi. So we go to our unit circle, and our value, our y value, our sine value here is going to be 0. So we go back to 0. And then we go to 3 pi over 2. So we go down to our unit circle, 3 pi over 2. What's our y value? -1. So we graph -1 here. And then we go to 2 pi. Now 2 pi is coming back this full rotation, and we go back to 0. So we're going to graph 0. Now we're just going to keep on repeating this pattern. You see how it starts and ends at the same point? Remember how I said it was a cycle? This is just going to keep on repeating forever. So we can go in the opposite direction. We can draw this. Essentially what this is doing, right, if I try to connect these dots, no promises. Something like that. It isn't the best. But essentially what this is doing is we are rotating around this circle. We keep on rotating and rotating and rotating. So that's why this is going to go on infinitely the x direction, because our angle, we can keep on going around the circle and around the circle, but it's always going to stay within these certain values. In this case, it's going to be, our range is going to be between 1 and -1 inclusive. Okay, so what's our amplitude? Well, our amplitude, right, as we set up here, it's going to be half the distance between the minimum and maximum value. So the minimum value here is going to be -1, right? It's going to be sort of this. It's going to be this right here, this bottom part. And then our maximum value is going to be up here, 1. So what's the distance between these two is going to be 2. We divide that by 2. It's going to be 1. Our amplitude is 1. Our period is going to be the distance. I'm going to do a different color. It's going to be the distance from this peak to this peak. And here, that's going to be 2 pi. And you can choose any point. This distance is going to be the same as this distance, right? It's just how long does it to go through that one cycle. So in this case, it's going to be 2 pi. What's our starting point? We're starting at 0. So I'm going to start at 0, 0. And then our scale. So our scale is basically just saying, you know, what are these values right here? So here we have pi over 2, pi, 3 pi over 2, 2 pi. I know it's hard to see, but this is our scale. Pi over 2, pi, 3 pi over 2, and 2 pi. And this is just going to set some benchmarks, easy benchmarks, for points we can graph so that we can graph our entire trig function. Okay, so cosine on the other hand. Let's do this. So we, on the x-axis, we have our angle. So what is our value of cosine when our angle is 0? Sorry, we go to our unit circle. 0 is our angle. What's our value of cosine? Our cosine is always going to be our x value. So it's going to be 1. So we're going to start at 1. What about at pi over 2? Well, our x value is 0 here, so our cosine value is 0. What about at pi? Well, here our x value is -1, so our value of cosine at pi is going to be -1. And then what's our x value at 3 pi over 2? 0. So we graph 0 here. And then we go back to 2 pi. We do 1 full rotation, and our x value is now 1. So our cosine value is 1. Okay, so we're just going to keep repeating this pattern. And it's going to look something like this. We can see that these two are very similar. These are actually going to be the exact same, except they're shifted horizontally. So here, what's our amplitude? Our amplitude is going to be half the distance from our minimum to our maximum. It's also just going to be this length if we... It's essentially just going to be how this length right here. So what's that length? That's going to be 1. Our amplitude is 1. Our period is from peak to peak, or from any point, how long it takes to go one cycle. So here, it's going to be this distance. That's again going to be 2 pi. Our period. Our starting point is going to be 0, 1. 0, 1. It's going to be this point right here. And then our scale is going to be the same. We're going to have pi over 2, pi, 3 pi over 2, and 2 pi. Okay. So here, we're given these equations, y equals a times sine of b times theta, and also y equals a times cosine of b times theta, where theta is in radians. So what's our amplitude? Our amplitude is going to be this number out in front, so it's going to be a. And what's our period? Our period is going to be 2 pi over b. And our scale is going to be whatever our period is over 4. Just so we can split it up into 4 different things like we did here. Our period here was 2 pi, so we split it up into 4 different sections. Okay, so let's apply this now. Our amplitude is a. In this equation, y equals 3 times cosine of 2 times theta. What's our a value? It's going to be 3. And what's our period? Our period is going to be 2 pi over b. In this case, our b value is 2. So that's just going to give us pi, right? Because those 2's cancel out. Our scale is going to be whatever our period is over 4. So we're going to have pi over 4. Here, same thing. Y equals 3/2 times sine of 1/3 times theta. We take our a value is 3/2, sorry. And our period is going to be 2 pi over 1/3. And essentially what we can do here is multiply by 3 over 3. 3 over 3 is just 1, so we're not changing this value. And on the top we get 6 pi, and on the bottom these two cancel out to just 1. So we get 6 pi. In our scale, we're going to do 6 pi over 4, right? Because our scale is our period divided by 4. And this will just simplify to 3 pi over 2. Okay. So let's do some graphing here. I'm just going to do the evens, but definitely use the odds as practice too. Okay, so here we have this equation, y equals cosine of 1/2 times theta. What's our amplitude? What's our number out here? We don't have any, so we're gonna have an invisible 1. It's like up here we did not have any value out here, and our amplitude was 1. Okay, so our amplitude is 1. What's our period? Our period is 2 pi over b. In this case, our b is 1/2. We multiply by 2 over 2, and we just get 4 pi. So our period is 4 pi. Our scale is going to be our period divided by 4. 4 pi divided by 4 is pi. And our starting point, well, let's plug in 0 for theta, and then we'll get our starting point. So what's 0 times 1/2? It's just going to be 0. So what's cosine of 0? We go to our unit circle, and it's just going to be 1. And I'm actually just going to, let's do 1 here. So this is going to be 1, this is going to be 2, this will be -1, and this will be -2. Okay, so we start at 0, 1. Okay, so now our scale is pi, so we do pi, then we do pi, then we do 2 pi, and then we have 3 pi, then we have 4 pi. This can also go in the other direction, -pi, -2 pi. Sorry, I thought for a second I miscounted. And then we have -3 pi, and then -4 pi. Okay, so let's plug in each of these things. So let's plug in pi for theta. Pi times 1/2 is just pi over 2. Cosine of pi over 2 is going to be 0. So we plot 0. Now let's plug in 2 pi. When we have 2 pi times 1/2, we get pi. So cosine of pi is just going to be -1. And ideally, if you can remember the unit circle in your head, that's going to be great. And on most tests or quizzes or SAT things, you're not gonna have the unit circle. So I'd say for Algebra 2, it's imperative that you know the unit circle, because it's gonna come up in calc, and it's gonna come up a lot in the rest of the math you do. So 3 pi, right? 3 pi times 1/2 is going to be 3 pi over 2, and we look here, the cosine of 3 pi over 2 is 0. So we can just continue this. 4 pi times 1/2 is 2 pi. If we look at our unit circle, that's going to bring us back to 1. So we have this. That is not, no, we're going to undo that. Sorry. It's going to look something like this. Right, this would keep on repeating down here too. Something like that. So this is how we'd graph that. Let's move on to this one. Our A value is 5, so our amplitude is 5. Period is going to be 2 pi over 1/3. And this just comes out to 6 pi. And then we have our scale is going to be 6 pi over 4. That's going to simplify to 3 pi over 2. And our starting point is going to be when theta is 0. Theta times 1/3, 0 times 1/3 is going to be 0. So what's sine of 0? If you go back to your unit circle, that's going to be 0. And then we do 0 times 5. And we get 0. So our starting point is going to be 0, 0. And right, just remember, this is our theta, this is our angle, and then this is going to, in this case, be our sine value. So we start right here. So I'm going to actually make this smaller, just because we need to be more precise. So here we're going to have 3 pi over 2. Let's zoom in a little. 3 pi over 2. Here we're going to have that times 2. So we're going to get 3 pi. Here we're going to have this next point. We're going to basically multiply this by 3. So we're going to have 9 pi over 2. Sorry, that does not look like a 9. And then we're going to multiply this by 2 or this by 4. And we're going to get 6 pi, right? Our period. Sorry. Okay. So, and this is, of course, 0. So, actually, I probably should not try that. Okay. It doesn't matter. Okay, so our amplitude is 5. So let's just make these units 1, 2, 3. Sorry, that does not look like a 2. 3, 4, 5. This is going to be -1, -2, -3, -4, -5. So we start at 1. At 3 pi over 2 times 1/3 is going to give us pi over 2. Sine at pi over 2 is going to be +1. So +1 times 5 is going to be 5. So we graph that point. 3 pi times 1/3 is going to be pi. Sine at pi is going to be 0. So 0 times 5 is just 0. At 9 pi over 2 times 1/3, we're going to get 3 pi over 2. At 3 pi over 2, our sine value is going to be -1. -1 times 5 is going to give us -5. And then we're just going to keep on repeating it. I'm only going to do this side, but just know that this is pattern. Ooh, 8, that is horrible. Just know, yeah, that's still really bad. Ooh. Just know that this pattern is going to continue in both directions. Something like that. Okay. Let's move on to 8. Our amplitude is our A value, 5 over 2. Period. Our B value is 1, so it's 2 pi over 1. It's just going to be 2 pi. Our scale is going to be 2 pi divided by 4, our period divided by 4. So we're going to get pi over 2. And here, one thing we can also do, we can start plugging this in, plug in 0 for theta and get sine at 0, and we're going to get 0, and then multiply by 5/2 and get 0. But sine values, trigonometric functions, unless you have some of these other transformations like vertical translations or things like that, it's going to be, our starting point is going to be 0. Whereas with cosine, it's going to be 1. If we look up here, our starting point was 0, 1. Here, our starting point was 0, 0. So in this case, our starting point is going to be 0, 0. So let's draw in our scale, pi over 2, pi, 3 pi over 2, and 2 pi. And this is 0. Based on our amplitude, what I'm just going to say is, let's do 1, 2, 3, 4. Then just use that. So -1, -2, -3, -4. Okay, so we plug in pi over 2. Sine of pi over 2 is going to be +1. +1 times 5/2 is going to give us 5/2. Wow, that looks like a star. Okay, now we have pi. Sine at pi is going to be 0. And 0 times 5/2 is just going to be 0. At 3 pi over 2, sine at 3 pi over 2 is going to give us -1. -1 times 5/2 is going to give us -5/2. And 2 pi, sine at 2 pi is going to be 0. 0 times 5/2 is 0. It's really important you know your unit circle. If you're having trouble or don't understand exactly how I'm coming up with these trig values, I'd say have a unit circle at hand just so you can cross-reference. But if I were to recommend, other than maybe exponent rules, knowing your unit circle is going to be one of the biggest things you should take away from Algebra 2. Okay, so let's graph tan. So it's going to be super helpful here for us to look at our unit circle and the value of tan. Well, first of all, tangent is going to be y over x, right? So what I want to ask you is, where do we not have a value for tangent? When is tangent undefined? Well, when is this sort of fraction or this, when is this going to be defined? It's whenever this, our denominator, is equal to 0. In this case, it's when x equals 0. So where does x equal 0 on our unit circle? It's going to be pi over 2. And here, 3 pi over 2. Which, by the way, we can also go in the opposite direction, right? We can have negative angles. 3 pi over 2 is going to be the same thing as negative pi over 2, right? So tangent is undefined at pi over 2 and 3 pi over 2 and all of those subsequent multiples. So I'm going to draw an asymptote here. We're just going to draw this. We'll do 2 sort of intervals. Okay. Sorry. 3 pi over 2. Okay. So here are our asymptotes. Now, whenever you're having trouble graphing, it doesn't matter what function it is, just start plugging in points. So let's plug in 0 for theta. When theta equals 0, let's actually do this. Oh, that's real bad. Sorry about that. This is going to be theta. This is going to be tan. So when theta equals 0, what is our value of tangent going to be? Well, let's go to our unit circle, sorry. Right, it's going to be y over x, 0 over 1. Tangent is y over x at theta equals 0. Sorry, our tangent is going to equal 0 over 1. So we're going to get 0 down here. Let's just graph that point. Now, we can keep on going further down. Let's do pi over 4. Pi over 4. At pi over 4, we're going to have root 2, right? Tangent is y over x. At pi over 4, we're going to get root 2 over 2 over root 2 over 2. And that's just going to give us 1, right? Those are the same values. Now, while we're up here, what about for negative pi over 4, or 7 pi over 4, right? This is going to be negative pi over 4. Sorry. Well, now we have y over x equals negative root 2 over 2 over root 2 over 2. And we end up getting negative 1. Ooh, sorry. I don't know why this tripped. Okay, so I'm going to put those 2 points here. And we can go even smaller. We can start plugging in, pi over 8 and things like that. But essentially what this is going to look like, our tan is going to look like this. It's almost going to look like a cubic, but it is not a cubic. and it's going to go on there, and it's going to approach these asymptotes, but it's never going to actually touch them. And this is just going to keep on repeating. So now it's going to look like this, and we're just going to get a bunch of repeating, sort of almost curvy functions. And these going infinitely upwards. Our range is going to be from negative infinity to positive infinity, but at things like negative pi over 2 or pi over 2 or 3 pi over 2, when we add that pi, these intervals of pi to pi over 2, or subtract them, we're going to have asymptotes. So given the graph y equals tangent, our asymptotes are going to be pi over 2 and negative pi over 2. Okay. So now let's talk about some phase shifts. Let's look down here, We're familiar with the A, we're familiar with B, but now we're introduced this H and this K. This should look familiar. When we were talking about quadratics and transformations of quadratic functions, we had H and K in our vertex form. A lot of these functions are as for transformations, they're gonna have a lot of similarities. So when we're subtracting H, we're going to be moving to the right, just like in quadratic functions. When we're adding H, that means we have to do almost like a theta minus negative H, So this negative H is going to shift us to the left. It's very much like quadratics. And this H is sort of inside our main almost function, our sine function, and that's what's going to allow us to horizontally shift. If we were thinking about quadratics, I'm not going to go too in depth on this, but let's just say we had something like 5 times x minus 3 squared plus 4. This minus 3 inside our main function where we're squaring this x, we're subtracting 3, that's going to be horizontally shifting us to the right. It's very similar here, where we're subtracting this h, whatever that may be, whatever constant that may be, it's going to shift us to the right. When we're adding this, if we were going to add 3 pi, that would be shifting us to the left horizontally. So inside our function is going to be horizontally. And this applies to things like absolute value functions too, things like that. So here we have this minus pi. This is going to be shifting pi units to the right. Here we have plus pi over 4. This is going to be shifting pi over 4 values to the left. One thing I will say is it's very important that you factor out your b value here, because things can get messy if you don't, and you'll have the wrong horizontal shift if you don't factor out that b value. Here we have plus k, just like up here where we're adding 4, that's vertically shifting us up 4. So plus k shifts up and minus k shifts down. Pretty simple. So this is shifting 2 units up, this is shifting 4 units down. Okay, so here, let's put it all together. This is going to be our amplitude. This is going to be it's going to relate to our period. Relate to period, which is essentially going to allow us to horizontally compress and stretch our function. So this is almost like horizontal stretch slash compress. And right, this is going to be our vertical stretching and compressing. This is going to relate to our horizontal shift or phase shift. Horizontal shift. This is going to relate to our vertical shift. Okay. So what's our midline? Our midline is just going to be basically the line to which the graph oscillates around. So here, shifting a graph vertically will create a new horizontal axis called the midline. The equation for the midline is going to be basically whatever our k value is. So it's going to be y equals k. Okay, so now we're going to describe some transformations. Here, what's our a value? 1/2, so our amplitude is 1/2. What's our period? Well, our period is going to be 2 pi over 3, our b value. So our period is just 2 pi over 3. Phase shift is going to be whether we're horizontally shifting. And this one thing here, it's easy to get mixed up, but we're talking this sine, we're taking sine of 3 times theta, not of 3 times theta minus 5. So just be sure of that. Otherwise, it would, if it was 3 times theta minus 5, it would have parentheses like that, but it doesn't. So we just have to assume it's sine times 3 times theta. So phase shift is going to be 0. We don't have any. Vertical shift, we're shifting down 5, right? Our k value is -5. So our midline is going to be y equals -5, right? This is the line. And our starting point is going to be, if we plug in 0, right, we do sine of 0 and we get 0. 0 times 1/2 is 0. Minus 5 is going to be -5, so we get 0, -5. Let's just do this real quick. Amplitude is our a value, 4. Period, notice how they factored it out for us, so that's nice. We have 2 pi over 2. That's just going to give us pi. Phase shift, we are going to be shifting left, right, because we're adding 2 pi, left 2 pi. Vertical shift, sorry about that, wow. We're going to be shifting up 1, which is our k value. And our midline is going to be our k value, so it's just going to be y equals 1. And then our starting point, let's plug in 0 for theta. 0 plus 2 pi is 2 pi. 2 pi times 2 is going to give us 4 pi. If we think about this on the unit circle, we can go back to the unit circle. But that's going to be, right, 2 pi is 1 full rotation. If we multiply that by 2, we're just doing 2 full rotations. We end up right back where we started. So what's cosine of 2 pi or cosine of 4 pi or cosine of 0? They're all going to be the same because we're adding 2 pi, so thus they're the same angle. Cosine of 0 is going to be 1. So we do 1 times 4, we get 4 plus 1 is going to be 5. So our starting point is 0, or sorry, our starting point, yeah, we can do 0, 5. At least this is going to be our y. This is going to be our y-axis. I'd actually say it might be better for us to say our starting point. Our starting point would just be, would just be, since this is a cosine value, our horizontal shift, we're horizontally shifting left, so negative 2 pi. We're shifting up 1, so we have 1. But since this is a cosine function, not a sine function, which starts at 0, since we have a cosine function, we have to include our amplitude, so we do 1, right? This is almost going to, right, remember, our cosine functions are going to look like this, if this is our function, or something like that. Here, we're going to have to add on this 4, right? Because our midline, let's just say, like, this is not to scale, but let's say this is 1. We're going to have to add on 4 to that to make this 5. I hope that makes sense. Also, you can use Desmos to, in the early stages, you can use Desmos to sort of help you out and just get more practice and cross-reference. So let me do some of these. So here we have a horizontal shift. Ooh, sorry. Okay, here we have a horizontal shift. We're adding pi over 2, so that means we're shifting left. Left, pi over 2. Left, pi over 2. Our amplitude is going to be our a value out front. That's just going to be 1. Our period is going to be 2 over our b value, which is just 2. So we do 2 pi over 2, and that just gives us, pi. And then our vertical shift, we don't have any vertical shift out here. Our midline is going to be basically what our vertical shift is, and that's nothing, so our midline is going to be y equals 0. Our scale is our period divided by 4, so we're going to do pi over 4. And our new starting point, since this is a sine function, we're going to start basically at 0, and we're shifting left, pi over 2, so we're going to have negative pi over 2, 0. Let's just draw this in real quick with the information. We just jotted it down. We have 0, and our scale is going to be pi over 4, pi over 2, 3 pi over 4, and then pi. And just for good measure, actually, let's do negative pi over 4, and then here would be negative pi over 2. Sorry, my writing is really bad. Okay, so our starting point is negative pi over 2, 0. So we're going to start right here. If we plug in negative pi over 4, negative pi over 4 plus pi over 2 is going to give us pi over 4 on our unit circle. Oh, now, sorry, my bad. We have to multiply by 2. 2 times pi over 4 is going to give us pi over 2. Sine of pi over 2 is just going to give us 1. And let's just have 1 here. 1, 2. So this is negative 1, negative 2. Then we plug in 0. 0 plus pi over 2 is pi over 2. Pi over 2 times 2 is pi. Sine of pi is 0. And pi over 4 plus pi over 2, if we have common denominators, that's going to come out to 3 pi over 4. Now we do 3 pi over 4 times 2, that comes out to be 3 pi over 2. Sine of 3 pi over 2 is just going to give us negative 1. And we can keep on repeating this. I had to do something. Okay, so we're doing this problem. What's our amplitude? It's going to be our a value. Here it's going to be 4. Our period is going to be 2 pi over b. In this case, we don't have a b value, or our b value is 1, so we're going to have 2 pi over 1, which is just 2 pi. Our phase shift, we're subtracting 3 pi over 2, so we're going to move right 3 pi over 2. Our vertical shift is going to be our k out here, so we're going to move down 1. Our midline, thus, is going to be y equals -1. Our scale is going to be our period divided by 4, so it's going to be pi over 2, pi, 3 pi over 2, and 2 pi, of course. Our new starting point. So I'll go over this because sometimes I feel maybe I did not explain it well before. When we're first going to shift right 3 pi over 2, right? So that's our x value. But our y value, we're starting, our midline is y equals -1. So we have -1 for our y value, but since this is a cosine function, if we scroll all the way up here, right, our cosine function here starts at 0, 1. We don't have any horizontal or vertical transformations, so it should be 0, 0, but since it's cosine, we're going to start at 1. We're going to go up by our amplitude, because our amplitude here is 1. So, or we could go down by our amplitude if our amplitude is negative. So here, we have a midline at -1, and then since we have an amplitude of 4, we gotta add 4 to that, so it's 3 pi over 2, 3. So let's mark this up. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And let's just do negative pi over 2. We'll do 1, 2, 3, 4, -1, -2, -3, -4. Okay, perfect. So we're going to start at 3 pi over 2, 3, up here. So if we plug in pi minus 3 pi over 2 is going to give us, pi minus 3 pi over 2 is going to give us negative pi over 2, For some reason my brain lapsed. Cosine of negative pi over 2, if we think about that on our unit circle, it's going to give us 0, right? But let's just use our unit circle. Here, right, 3 pi is going to be the same thing as negative pi over 2, because we're going to do negative pi over 2 is going in the opposite direction. 3 pi over 2 is going to go this way. Anyways, our cosine value is going to be 0 since our cosine value is x. So we have 0. It's this one. We have 0 times 4 is 0 minus 1 is going to be -1. So we get something like that. And then we do pi over 2. Pi over 2 minus 3 pi over 2 is going to give us approximately pi, or negative pi, and cosine of negative pi is going to be -1. -1 times 4 is -4, minus 1 is going to be -5. So we get to this. Then we go back here. So I'm going to start connecting these dots. Wait, my bad. This is here. And then this goes back to our midline 0, and then this goes back up here. And you can start to see the pattern I'd recommend plugging in all your points on an actual test, but if you can recognize the pattern, then just go with that. And this extends in both directions infinitely, right? Okay, so let's just do this problem real quick. Our amplitude is our A value. In this case, it's 2. Our period is going to be 2 pi over b. B is 2, so 2 pi over 2 is just pi. Phase shift, we're subtracting pi over 2, so we're going to move right pi over 2. Vertical shift, we're shifting up 1, right, since we have that plus 1 at the end. Our midline, thus, is going to be y equals 1. Scale, it's going to be our period divided by 4, so pi over 4, pi over 2. Right, with this scale, I'm just multiplying whatever our 1/4 of our period is. I'm going to multiply by 2, so pi over 4 times 2 is pi over 2. Then we're going to multiply by 3, so we get 3 pi over 2. Sorry, 3 pi over 4, and then I'm going to multiply by 4, which will get us right back. Our starting point is going to be, well, we're horizontally shifting right pi over 2, and then we're shifting up 1. But since this is a sine function, our starting point is going to be almost like a 0 with respect to our horizontal and vertical shifts. All right, so if we graph this to our scale, we have 0, then we have pi over 4, we have pi over 2, then we have 3 pi over 4. I'm going to go in this opposite direction, negative pi over 4. And then you know what, I'll do one more for good measure. Negative pi over 2. Okay, so here, let's do our this. Okay. -1, -2, -3, -4. Okay, so what's our starting point? Pi over 2, 1. So let's graph right here. And our midline is y equals 1, right? So it's going to oscillate around that. So let's plug in pi over 4. Pi over 4 minus pi over 2 is going to give us negative pi over 4. Negative pi over 4 times 2 is negative pi over 2. If we go in our unit circle, sine of negative pi over 2 is going to give us negative 1. Negative 1 times 2 is negative 2. Negative 2 plus 1 is negative 1. So put that right here. I know it's hard to see, but there's a point right there. Then let's plug in 0. 0 minus pi over 2 is going to be negative pi over 2. Negative pi over 2 times 2 is negative pi. Sine of negative pi is going to be 0. 0 times 2 is 0, plus 1, 1. And then if we do negative pi over 4, negative pi over 4 minus, negative pi over 4 minus pi over 2 is going to give us negative 3 pi over 4. Negative 3 pi over 4 times 2 is negative 3 pi over 2. And if you can imagine that on the unit circle, or if you add 2 pi to that, it's going to be the same as pi over 2. And so sine of pi over 2 is going to give us 1. 1 times 2 is 2. 2 plus 1 is 3. I know I'm going fast, but maybe just, if you're having trouble understanding it, or each and every step, maybe pause it, take it slow, look at your unit circle. This is just going to be our cycle. This will repeat in both directions. If you have any questions on trig graphing as a whole, I think I uploaded another video that can help. But yeah, just use all your resources. Go to Mr. Whitaker, or any of your math teachers, go to tutoring center. Feel free to reach out to me. Watch videos. Just use all of your resources. Yeah. See ya.